Welcome to Lecture 22, Solubility for Ionic Compounds. Go to the next slide. This is actually the first slide that we want to look at. First, I want us to remember what we covered in the last lecture involving ionic compounds. You can see here ionic compounds that are soluble and dissociate completely produce the number and types of ions depicted by the ionic formula. So you can see sodium chloride is an ionic compound because in aqueous solution it's going to separate into its ions, the sodium ion, which is a cation, the chloride ion, which is an anion. Notice the little AQ means that it has dissolved in water and dissociated. Here's calcium nitrate. Notice there's an S by each of these. That means they're a solid until they go into aqueous solution. And in this case, form a calcium cation and a nitrate anion. Notice 2 plus and a minus. We studied the handout called cations and anions that are used to form ionic compounds. You want to refer to that to understand why these charges are like they are. You need to be able to use the table, and eventually you'll have to memorize the table. And here's ammonium sulfate, the ammonium ion, and the sulfate ion. Notice to balance the equation we put a 2, coefficient 2 in front of the ammonium on the right side of the reaction. But here we've got ionic compounds. Let's go to the next slide. Okay, precipitation reactions. They occur when one of the products forms a precipitate or comes out of solution. When two solutions are mixed and a solid is formed, the solid is called a precipitate, abbreviated PPT. We can have two solutions, we'll have some examples in a minute, of compounds that are mixed. And then they form new compounds that are not soluble, but they may start out being soluble in the solution. Then they change into a different kind of compound that becomes insoluble. When two solutions that contain soluble ionic compounds are mixed, if one or more of the resulting ionic compounds is insoluble, the insoluble compounds will precipitate out of solution. They literally fall out of solution. They become solids. They settle to the bottom of the beaker. Following a set of solubility rules, the solubility of ionic compounds can be somewhat predicted. This is a very important table for you to understand how to use. You don't have to memorize these rules, but eventually you will in later courses. And notice it's called precipitation reactions, and it's divided into two parts. Soluble ionic compounds. These are compounds that contain these various anions. And then down here, this part of the chart, insoluble ionic compounds contain these anions. So if they contain these ions, they're insoluble. If they contain these up here that are listed, they are soluble. However, now you need to pay attention to the exceptions over here on the right. The exceptions mean that if you have a compound containing the nitrate anion, there are no exceptions. They are always soluble. Also with this ion here that you see, C2H3O2, there are no exceptions. However, if chloride is in a compound, it is normally soluble. However, if it's bound to silver, such as silver chloride or mercury chloride or lead chloride, it's going to be insoluble. It will not be soluble in water. Here are the exceptions down here too for these various anions that are listed. These, if they're in a compound, are typically insoluble, but these are exceptions over here. For example, ammonium sulfide is an exception, which means it is soluble. It's not insoluble. It's an exception. Also down here, ammonium carbonate is an exception to the rule. Carbonate normally in a compound makes it insoluble. So you have to be able to use this table, and we'll use it when we look at some examples and in the homework. You have to look at it very carefully and follow it. And again, these are typically soluble if they're in a compound. These are typically insoluble, but these are the noted exceptions. So let's look at this. Here is prediction of solubility. If aqueous solutions of barium nitrate and sulfuric acid are mixed, we're going to get barium sulfate, BaSO4. The cation in this compound will join up with the sulfate or the anion in this compound. They dissociate into all their ions, and barium will match up with sulfate. The hydrogen will match up with the nitrate. They just switch places. Barium goes to sulfate, proton or this hydrogen goes to the nitrate, forming barium sulfate, BaSO4, and the other compound is hydrogen nitrate or nitric acid. Both of them are formed from this reaction. If we go back to the table, precipitation reactions table 4.1, we see that barium sulfate is insoluble because sulfate is listed up there in the top of the table, and it says that it will form soluble ionic compounds with the exception of, and it's listed on the right, barium is included. So barium sulfate is insoluble and will precipitate out. Nitric acid, or HNO3, is soluble because it has the nitrate ion NO3, and there are no exceptions. It is always soluble. So barium sulfate will precipitate out of the solution. Sometimes you'll see a downward arrow right after the compound as it's written. Let's look at some other examples. Here's another example of sodium chloride and calcium sulfate. Sodium chloride, calcium sulfate will form sodium sulfate, NaSO4, plus calcium chloride, CaCl2. So sodium has a +1 charge, sulfate has a -2, so it's going to take two atoms of sodium to match up with one SO4. So it's going to be Na2SO4 aqueous, because it will go in solution, it is soluble, plus calcium chloride, CaCl2, is also aqueous and is soluble. If we go back to the table 4.1, we see that sodium sulfate is soluble and calcium chloride is soluble. So nothing will precipitate out of solution. Here is a copy of the homework for this lecture, and I've illustrated 3 different problems here for you. You can see that here's what we're asked to do is write the products of each reaction, include the phases of each product. Notice this is aqueous, and these compounds are going to form. Circle the precipitate of each reaction. In other words, the precipitate is the compound that's insoluble of the 2 products, or both of them possibly, or neither of the 2. If there is no precipitate, write no precipitate. Here's an example down here we'll get to in just a second, where both of the products that are formed are soluble compounds. Make sure your reactions are balanced. Notice here, barium cation will bind with sulfate anion and form barium sulfate, which is insoluble because the sulfate ion, when it's bound to barium, is insoluble according to table 4.1. Potassium nitrate, the potassium ion right there will bind with the nitrate ion, and that should be NO3, and it will form a soluble compound because all compounds containing NO3 are soluble. This is insoluble, so it is the precipitate. I've circled it. And notice here, silver nitrate plus sodium iodide. The silver cation will bind with the iodine anion, forming silver iodide, which is insoluble because iodine is in the table, and when it's bound to silver, it is insoluble. It's an exception. And also, sodium nitrate. Sodium nitrate is soluble because sodium is bound to nitrate, and nitrate has no exceptions. It is always soluble. Then number 5 is an example where both of the compounds created are soluble. Ammonium phosphate and sodium nitrate. Again, all nitrates are soluble. And phosphate and ammonium, if we look in our table, ammonium ions, let's see, where is it? PO4 phosphate ions are listed in the second half of the table. And an exception, it is normally insoluble when it's in a compound, but when it's bound to the ammonium ion, that is an exception. Therefore, it is soluble. So neither of these are insoluble, so there is no precipitate. And that concludes this lecture. Now, your task is to practice and looking at these, the products of these reactions.